मैं तब से बोले जा रहा हूँ। चलो भैया, प्रतीक्षा बता दिया, नहीं तो मैं तो बकबक करते रह जाता स्क्रीन के साथ। तो पानी पीने दो। Okay, so start once again. हाँ, एक मिनट तो लिखा, अनम्यूट कर लो तो लिखा, आई थिंक हो जाना चाहिए।
सर गलती से हो गया था।
अच्छा, गलती से मैंने भी अनम्यूट। Okay, let me start again. So we have been looking at the law of conservation of linear momentum. There are basically three types of questions that you'll find on the law of conservation of linear momentum. One is where the law itself is sufficient to give you answers, like we saw. Another is where the law of conservation of momentum is to be used in conjunction with some other law. That means that the conservation of momentum plays a secondary role or a supportive role in finding out whatever is unknown in the given problem. And the third is a very specialized topic called collisions. Right? So we will see collisions later on. In the last class, we saw that applying the law of conservation of momentum on a system gives us whatever was asked in the question. Today, we are going to see how law of conservation of linear momentum is applied in conjunction with something else. Okay. So I'll start off very simple, very easy question. So we have a wedge of mass m and a block of mass m. It's moving with velocity v naught. The wedge has a circular cross section of radius r. No friction is there anywhere. Find minimum V naught so that M just reaches the top of the wedge. नहीं शाना, गलत आंसर है। फ्रिक्शन कहीं नहीं है, इसका मतलब जो वेज है वो भी मूवेबल। हाँ बिल्कुल सही। Okay, so how do we? हाँ सही है। So it is the aim of the series of lectures that we are having that you should migrate, or at least you should assimilate thinking which encompasses multi-particle systems. I will reiterate, I will say this again, that अभी तक आप लोग केवल single particle system से deal कर रहे थे. Now you need to train your mind how to deal with multi-particle systems. The first thing, of course, is that you have to decide on the system itself. So in this case, I will take the block and the wedge as the system. Now you have a series of tools that you have to apply on this multi-particle system, which will lead you to the answer, which will lead you to a knowledge about what is happening in the system. Bilkul sahi. So what are these tools? Well, the first tool is that the external force must be equal to mass into acceleration of center of mass. Right? That is the first tool we have. Second tool, which we have actually seen before, but I want to discuss it again now, is that the summation of work done on the system is equal to the change in kinetic energy of the system. And the third tool that we have learned is that if summation of F external is equal to 0, if summation of F external is equal to 0, then this means that the momentum of the system, linear momentum of the system, is constant. So when to use the tools and when to not use the tools? Well, these three things are sometimes only third is enough, sometimes only two is enough, sometimes only one is enough. Sometimes you'll have to apply one and something else, some geometrical constraint equation. Sometimes you'll have to apply 2 and 3 together. Okay. You may have to apply 1 and 2 together. So when do you apply one or the other? When do you decide? What is the rationale? What is the thought process that you should have? We have actually discussed this. If in the question they are asking for velocity or they are asking for displacement, then the first choice must be the work energy theory. In 99.99% of the cases, work energy theorem will do the job. If after the application of work energy theorem there are still unknowns remaining, then you have to either apply 1 or you have to apply 3 or maybe something else. So in this case, let me first apply 2 because they are asking me for velocity. So let me apply the work energy theorem. So how to apply the work energy theorem? Remember, we have done this. Work energy theorem. Summation of work done on M plus summation of work done on capital M must be equal to the change in kinetic energy of M plus change in kinetic energy of capital M, right? So it's basically you write the work energy theorem for the block, you write the work energy theorem for the wedge, and you just add it up, and that's it. Now, when you want to figure out the work done on small m, you will write work is done on small m by the gravity by Earth plus work is done on small m by the normal reaction. So normal reaction is there due to the floor as long as small m is on the floor, and then the normal reaction on m is due to the wedge plus work done on capital M by normal reaction. So as capital M moves, there are two normal reactions on it. One is due to small m, and the other is due to the floor on the wedge. So I don't want to write this. I don't want to break this up into two other work dones. Ideally, it should be like that. But so as we have discussed before, this guy and this guy, they will always add up to 0. They will add up to 0. So work done on the system is only work done on m by gravity, which is going to be minus mgr as it is going to reach the topmost point of the wedge. This will be equal to the final kinetic energy. This will be equal to the final kinetic energy, that is half mv square plus half mv square. Right now, both of them have got kinetic energy now. The block has got the kinetic energy, and the wedge has also got kinetic energy. Why is it that I have taken their velocities to be same? The reason is that m just reaches the top of the wedge. Okay? Just reaches the top of the wedge. This means that the final location of m is going to be somewhere here, and since it is at the highest point, therefore its velocity in this direction will be 0, or in this direction will be 0. And since this surface of the wedge is in contact with the surface of the block, therefore their velocities in this direction must be same. Nahi to contact chut jayega. So at the topmost point, the velocity of the block and the velocity of the wedge have become 1, same value. Minus the initial kinetic energy, which is half mv naught. ठीक है, तो मैंने वर्क एनर्जी थ्योरम लिख दिया, लेकिन इसमें दो अननोन्स. एक ये v अननोन है और एक ये v नॉट अननोन। इसका मतलब आपको कुछ और चाहिए यहाँ। प्लीज टेल मी कि ये कुछ और क्या होगा। इनफैक्ट डोंट टेल मी। हाँ, just write down the other equation for this system of two particles like we discussed in the last class, and then solve and tell me the value of v naught. And I'll give you another question which is a continuation of the first question. If given velocity is 2v naught, then find the maximum height to which the block rises.
So the height of the wedge is same.
I hope everybody has got the answer for the first part. So this will be that from law of conservation of momentum, we will get initial momentum. First, summation of f external along the x-axis is equal to 0. Since there is no friction, initial momentum is equal to mv naught plus 0. Final momentum is equal to m plus mv naught. M plus mv, sorry. So we get v नहीं मेरे ख्याल से आई डोंट थिंक सो ये आंसर। हाँ, इसमें v स्क्वायर की वैल्यू डालो ना, v नॉट। हाँ सही तो है। This gives me v is equal to mv naught upon m plus n. So we get वाले इक्वेशन में डालना है हमको, माइनस एम जी आर इज इक्वल टू हाफ m plus m into v square, which is m square v naught square upon m plus m whole square, minus half m v naught square. So this is minus 2gr is equal to, ये 2 और 2 लेफ्ट हैंड साइड में ले आया, is equal to m v naught square, एक m कैंसिल हो गया थ्रू आउट, यहाँ पे m प्लस m कैंसिल हो गया एक, माइनस वी नॉट स्क्वायर। हाँ उसमें वी नॉट डालो ना, वी नॉट की वैल्यू डालो, देखो आर के टर्म्स में आएगा ना, सो वी गेट माइनस 2gr is equal to minus mv naught square upon m plus m. So v naught is equal to root of 2gr m plus m by capital M. ये अंशुल जो आंसर दिया है ना, इसमें वी नॉट स्क्वायर की जगह वी नॉट जो लास्ट लास्ट ये जो मैंने
हाँ सर
निकाला
डाला
है,
सर, तो 4 कैपिटल एम आर बाई स्मॉल एम।
फोर आर आएगा, देखना ना जरा, एम नहीं आता है, एम और एम नहीं आता है।
अच्छा हाँ सर सॉरी सर, वो कैपिटल एम कट जाएगा।
लेकिन 4R तब आएगा ना जब वो बॉल, मतलब जो मास है वो वेज से कनेक्टेड रहा लास्ट में।
क्या क्या
सब मतलब जो सेकंड क्वेश्चन था उसमें 4R तो तब आएगा ना जब वो मास कनेक्टेड रहा लास्ट में।
कनेक्टेड है
मतलब जैसे इस वाले क्वेश्चन में जो हमने मतलब लास्ट में एम मतलब वेज का और ब्लॉक का दोनों का वेलोसिटी सेम था ना, क्योंकि वो वेज और ब्लॉक दोनों कनेक्टेड थे लास्ट में। तो सर सेकंड क्वेश्चन जो है उसमें भी कनेक्टेड ही रहेगा ना।
छोटे डायग्राम बनाता हूँ, वो बचपन में ना ये क्या करते थे हम लोग, हाँ क्या करते थे कि एक वो फ्लिप फ्लिप कॉमिक बना लेते थे हम। तो व्हाट यू डू इज वो अलग अलग पेजेस पे ना यू मेक द डायग्राम विद स्लाइट चेंजेस एंड देन यू फ्लिप द पेजेस एंड इट सॉर्ट ऑफ कम्स इनटू एन एनिमेशन। सो आई कांट डू दैट, but the first part of the question will be something like this. This is moving, this is stationary. Now both are moving. Now both are moving horizontally. Now both are moving again. Can you guess question 2 में क्या हो रहा है? Oops. Question 2 में very good physics was. Question 2 में this guy is moving, this guy is stationary. Now this guy climbs on top. This guy goes beyond. Maybe it goes further up. So it is this height that I am interested in. देखा नहीं आया ना, कांटेक्ट में नहीं है ना।
हाँ सर वो समझ आ गया सर, लास्ट में वेलोसिटी सेम ही रहेगी।
वेलोसिटी सेम ही रहेगी क्योंकि वर्टिकल वेलोसिटी उसकी 0 हो जाएगी।
हाँ सर।
हाँ बिल्कुल। For those of you who have done question 2, question 3, find, but first you have to answer this. ये लैंड कहाँ करेगा? लैंड कहाँ करेगा? बहुत बढ़िया शेयर, यस।
वेज पे वापस
सब वेज पे ही लैंड करेगा।
बिल्कुल बिल्कुल, यस यस यस, इट विल लैंड हियर ओनली। हाँ, एक मिनट, हो गया, लिख लिया, स्क्रीनशॉट ले ले मिला। So question 3 is find the time of separation of wedge and block. Question 2. So now what I'm doing is that I am sending the block with a velocity of 2v0. V0 we've already found. So what is going to happen is that this guy is now going to climb the wedge, but this time it will not stop at the topmost point because v0 was the minimum velocity for which it reached the topmost point, just reached the topmost point. Now it is going to leave the surface of the wedge. It is going to leave the surface of the wedge. And somewhere in the future, and sometime in the future, it is going to reach its maximum height. So continuing with the concept of multi-particle systems, I will choose this as the system. Therefore, this is the evolution of the system. This is how the configuration of the system is changing, evolving with time, right? And this evolution of the system is subject to certain laws. The evolution is not random. What are the laws? Number one, the work done on the system must be equal to the change in kinetic energy of the system. The momentum of the system along x direction must remain constant. Whatever happens, the momentum of the system along x direction must remain constant. Because there is no external horizontal force acting on the system from beyond the blue boundary. So therefore, I'm going to apply now the work energy theorem, which will give me minus mgh is equal to the final kinetic energy minus the initial kinetic energy. Now, what is this V1 and what is this V2? V1 is the yes. V1 is the velocity of this block at the highest point, and V2 is the velocity of this wedge when the block is at its highest point. Now by definition, highest point का मतलब होता है that vertical component of velocity is 0. Therefore, here there will only be a horizontal component of velocity. And this is many ways constrained to move along the horizontal direction, तो इसकी तो horizontal velocity होगी. Now the thing is that when this block reaches this point, then it is guaranteed that the horizontal velocity of the block and the horizontal velocity of the wedge will be same, because of the fact that the surfaces here which are interacting with each other are vertical. Therefore, the horizontal velocities must be same. Otherwise, the block will lose contact along the horizontal direction, which we don't want to happen. So if at this position the horizontal velocities of both the block and the wedge are same, then in this position also the horizontal velocities of the block and the wedge must be same, because the moment the block surpasses the wedge, there is no external force individually along x-axis either on the wedge or on the block. Therefore, their velocities along x-axis must become constant, both their velocities. And this should continue throughout the motion when the block is not in contact with the wedge. Okay, so then we get minus mgh is equal to half mv square plus half mv square minus half m into 4v naught square. Okay, and then from conservation of momentum, so this is, let's say, scenario 1, let's say this is scenario 2, then m into 2v naught is equal to m plus m into v. Now I'm going to just substitute everything inside. So this will be half m plus m into v square. V square is equal to 4 m square upon m plus m whole square into v naught square. So I don't want to write v naught square. I will write the value of v naught from here. I'll simply put in the value of v naught from here. So this will be equal to 2gr m plus m upon capital M minus 2m into 2gr m plus m upon capital M. Okay, m plus m square यहाँ से उड़ गया, एक m इधर से उड़ गया. Okay, so the equation that I end up with is minus gh is equal to ये 2 और 2 उड़ गया is equal to 4m by m minus यहाँ पे आएगा gr minus 4gr m plus m upon m. This is equal to minus 4mgr upon m. And now minus g cancels out, mm cancels out, and I get h is equal to 4. Okay, so it will go up by a distance of 4. I hope this is clear to everyone. If there is a doubt, please do ask. I will repeat. So now please do this question. And for those of you who have done this, question 4. Find हाँ बताओ प्रतीक्षा क्या होगा? Tell me. Find the eventual velocities of the block and the wedge. क्या होएगा? Will it be vertical motion or will it be projectile? हाँ, मेरा आंसर सुनना है. मेरा आंसर है दोनों. My answer is both.
सर वो तो किसके रिस्पेक्ट में देख रहे हैं वो?
Very good, Shivam. Yes. So if I'm standing on the block, on the wedge, ठीक है, तो मेरे को ये वर्टिकल मोशन दिखाई देगा. ब्लॉक ऊपर गया, फिर नीचे आके वहीं लैंड कर गया. हाँ शौनक, यस. लेकिन अगर हम इसको साइड से देख रहे हैं, वी आर लुकिंग एट इट फ्रॉम द ग्राउंड, राइट, देन इट विल बी लाइक दिस. ये देखो मैंने ड्रॉ किया है ना, देन इट विल बी लाइक दिस. मोशन ऑफ द, यहाँ से प्रोजेक्टाइल शुरू होएगा, यहाँ पे प्रोजेक्टाइल. So to find the time of separation, I realize the fact that from this point, there will be projectile motion until the object lands back on the wedge. So basically, all I have to do is find the time of flight of the projectile. So this must be equal to the time of flight of the projectile, which is equal to 2uy upon g, which is equal to 2uy upon g. Okay. Now I also know that the maximum height of this projectile is 3r. Okay, not from the ground, but from the top of the wedge, from where the projectile started. And I also know that H is equal to uy square by 2g. This implies that uy square by 2g is equal to 3r. This means that uy is equal to root 6gr, and therefore the time of the projectile, which is 2uy upon g, will be equal to root of 6r by g. End of statement. कोई वर्क एनर्जी थ्योरम या कुछ नहीं लगा. However, if you say कि नहीं नहीं मेरे को तो ये uy निकालना है,
सर इंटू 2 भी होगा ना शायद.
हाँ
सर इंटू 2 भी होगा ना एक यहाँ पे टाइम फाइनल में.
हाँ सर.
So now if you say कि नहीं 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 मेरे को तो केवल ये और यहाँ से uy निकालना है. Okay. In this case, what you will do is you will write down minus mgr is equal to the final kinetic energy, which will be v square plus vy square. इसकी वेलोसिटी vy ऐसे है और v ऐसे है, इसकी भी वेलोसिटी v ऐसे होनी चाहिए, प्लस हाफ कैपिटल M v square minus the initial kinetic energy, which is half m into 2v naught. And then you can conserve momentum along the x-axis, and you can say that m into 2v naught is equal to m plus m into g. यहाँ से भी अगर आप vy निकालेंगे तो एग्जैक्टली यही आंसर आएगा. Okay. The reason why I am telling you this, I wanted you to notice the subtlety that exists between this point and the same point in the previous question. In the previous question, that means the first question, this Vy was equal to 0. But in the subsequent question, at that topmost point, Vy for the block will not be 0. G is acting as an external force along the y-axis. इसलिए मेरे पूरे डिस्कशन में मैंने y-axis के along कुछ नहीं किया, मैंने बात भी नहीं करी y-axis, except for the fact that जब मैं maximum height पे हूँ तो velocity 0 होएगी. Except for that, I did not even bother about the y-axis.
सर और इंटरनल फोर्स इधर पे mv स्क्वायर बाय r इंटरनल हो जा रहा है.
इंटरनल फोर्स mv स्क्वायर बाय r नहीं है, क्योंकि mv स्क्वायर बाय r तो मास इनटू एक्सेलरेशन होता है ना. नॉर्मल रिएक्शन इंटरनल फोर्स है. वो नॉर्मल रिएक्शन की वजह से एक mv स्क्वायर बाय r आएगा डेफिनेटली. लेकिन if you ask me the blue boundary that I have drawn, what is the internal force within that blue boundary? It has to be normal reaction.
सर नेक्स्ट क्वेश्चन में इवेंचुअल स्पीड्स मतलब लैंड करने के बाद या मतलब स्लाइड डाउन करने के बाद स्पीड निकालना.
फाइनली क्या होने वाला है?
सर नीचे स्लाइड डाउन कर जाएगा.
ये आएगा, यहाँ पे नीचे आएगा और फिर
हाँ,
नीचे
सर.
स्लाइड डाउन कर जाएगा. ये ड्यूरेशन में इस वेज की वेलोसिटी और बढ़ेगी या कम होगी?
बढ़ेगी ना सर.
बढ़ेगी.
बढ़ेगी, हाँ. And then finally, what is going to happen is, after a long time, this block will be moving in this direction and this wedge will be moving in this direction. So that is what I want, final velocities. आओ भाई, क्या हुआ? सब लोग शांत हो गए? So if this is the eventual picture, so then I'll apply the work energy theorem. Let me. Wow, Tarun. So this is the initial picture. This is the eventual picture. ये हमारा बाउंड्री है. इनिशियली ये V0 से जा रहा है, 2V0 से, और फाइनली V1 से इधर आ रहा है, V2 से इधर जा रहा है. V1 की डायरेक्शन तय नहीं है, V1 की डायरेक्शन उल्टी भी हो सकती है. आई डोंट नो, आई हैव नो आइडिया, मैंने बस डाल दिया. So again, let's apply the work energy theorem. Summation of work done is equal to 0. There is no work done. Should be equal to change in kinetic energy. So 0 is equal to the final kinetic energy minus the initial kinetic energy and then conservation of momentum. Initial momentum is m into 2v0. Final momentum is minus m into v1 plus m into v2. Now I have written minus mv1. Okay, I can omit the minus sign. If I omit the minus sign, इसका मतलब ये हुआ कि मैं velocity v1 ऐसे लेके चल रहा हूँ, which is absolutely okay. Which is absolutely okay. अगर मेरा assumption गलत होएगा तो ऑटोमेटिकली मेरा आंसर
सर कैपिटल M/V2 होएगा ना?
हाँ
सर कैपिटल M into V2 होगा.
हाँ कैपिटल रब करने का देख रहा हूँ. Okay, simultaneous equations solve. आंसर आ गया.
सर ये बहुत लंबा जा रहा है.
ऐसा मत बोलो यार.
हाँ सर.
अच्छा. So basically what is happening is that you have half m into 2v0 square is equal to half m v1 square plus half m v2 square. And we have ये वाला expression which is m into 2v0 is equal to m v1 plus capital M v2.
तो यहाँ पे 2v0 क्यों आया? v0 से भेज रहे ना?
मैंने 2v0 से यार.
अच्छा.
v0 से तो जस्ट ऊपर पहुंच के वो फर्स्ट क्वेश्चन में कंडीशन थी ना, मैंने निकाला था v0 की.
तो मुझे लगा v0 से.
कोई फर्क नहीं पड़ता है. The procedure will be same, the answer will be slightly different. So how to solve this very weird simultaneous equation?
ऊपर वाली में कैपिटल M मल्टीप्लाई कर देंगे.
नहीं, मेरे को नहीं करना. और बता कोई रास्ता.
डिवाइड कर दे दोनों इक्वेशन को.
नहीं नहीं नहीं, देखो ऊपर वाली इक्वेशन में मैं 2 को दोनों तरफ से कट कर दे रहा हूँ, मतलब ये जो हाफ वाला फैक्टर है मैंने उड़ा दिया, और उसके बाद से मैं चाहता हूं कि दोनों इक्वेशंस में, राइट, एंड दिस इज अ स्टैंडर्ड टेक्निक, दोनों इक्वेशन में ये जो m वाले टर्म्स हैं ये एक तरफ रहे, कैपिटल M वाले टर्म्स एक तरफ रहे। मेरे पास आएगा, पहले इक्वेशन का आएगा m इंटू 2v0 माइनस v1 इज इक्वल टू कैपिटल M v2, और दूसरे वाले में आएगा m इंटू 2v0 स्क्वायर माइनस v1 स्क्वायर इज इक्वल टू m v2 स्क्वायर। दिखाई दे रहा है क्या करना?
डिवाइड करना।
डिवाइड, अब डिवाइड करो। अब जब आप डिवाइड करोगे तो फैक्टराइजेशन से 2v0 प्लस v1 बच जाएगा, दूसरा फैक्टर उड़ गया, और दूसरे साइड केवल v2 बच जाएगा। Right, so you are actually left with a very simple equation now. So let's put in the value of v2 here and get the value of v1. M into 2v0 is equal to m into v1 plus capital M into 2v0 plus v1. And I want to write this very properly. Okay? I want to write this very properly. So what I do is I write it like this. M minus m into 2v0, ठीक है ना, ये वाला टर्म इधर ले गए, इज इक्वल टू m plus m into v1. Right, I'm going to change the slide. So I get v1 is equal to small m minus m, capital M minus small m minus m. So this is equal to m minus m upon m plus m into 2v0. And v2 will be equal to how much? कितना आएगा?
सर एक सेकंड प्रीवियस पेज पे जाएंगे। ओके सर,
ये बताओ v2 कितना आएगा? 2v0 प्लस v1 ही तो करना है, 2v0 प्लस v1 ही तो करना है, आएगा
So minus 4mv0 by m plus m.
माइनस नहीं आएगा, देखो
हाँ सर,
सर क्या
माइनस नहीं आ रहा, प्लस है,
क्या प्लस क्या?
प्लस 4mv0 by m plus m.
I don't want to write it like this. I want to write it like 2m small m capital M
Small m
upon m plus m into 2. अब हो गया ना सबका? ये समझ में आया सबको? Everybody has understood this? Anybody who has not understood? Anybody who has not understood? शौनक आया समझ में तेरे को?
Yes, sir.
अरुण?
यस सर।
सर एक डाउट था।
हाँ
सर अगर स्मॉल m कैपिटल M से बड़ा हो गया,
हाँ,
मतलब पहले इक्वेशन में ब्लॉक आगे मूव करेगा, बट सर लैंड होने के
yes. See, the result is coming to us naturally. Shivan? If M is greater than capital M, then it is guaranteed that this will happen. And if M is less than capital M, which generally is the case, then it is guaranteed that the eventual velocity of this block will be in this direction. M is less than. अब जिन लोगों ने चैप्टर पहले किया हुआ है, ये याद आ रहा है क्या चीज है ये?
सर एटवुड मशीन का
हाँ?
एटवुड मशीन का
नहीं 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 नहीं, मैं अभी कहाँ चैप्टर किया है ये? उत्कर्ष
सर कोलिजन में जब E1 हो जाता है तो उसके V1 V2।
हाँ, कोलिजन का फॉर्मूला मतलब कोलिजन का डायरेक्ट वर्ड. So this is also collision. Okay? This is also collision. So those of you who have not done, don't worry. Again, correct. This is exactly what happens in collision. This is exactly what happens in collision. So two objects, they interact with each other, and then when the interaction stops, their velocities are different. That is what is collision. Okay, चलो आगे बढ़ते हैं. I think only one question more I'll give because so find velocity of wedge as block reaches bottom. No friction anywhere. नहीं तरुण गलत है। नहीं पार गलत। नहीं अनीश गलत। नहीं उत्कर्ष गलत। संचय
सर राइट है, सर राइट है।
अच्छा लग रहा है मेरे को इसमें कुछ। क्वेश्चन पहले किया है ना तूने?
हाँ सर पता है, किया था एक बार।
कहाँ पे है?
सर HC वर्मा में ना शायद से।
HC
याद
वर्मा
नहीं।
में HC वर्मा में सेंटर ऑफ मास वाले चैप्टर में एक्सरसाइजेस के लास्ट पेज पे ये क्वेश्चन है। प्लीज कंपेयर योर आंसर विद दैट।
अच्छा ठीक है
आंसर
सर।
हाँ एक बार कंपेयर कर। बाकी जिन लोगों ने आंसर दिया है प्लीज कंपेयर। HC वर्मा में सेंटर ऑफ मास चैप्टर में लास्ट पेज पे ये क्वेश्चन दिया है। आई डोंट रिमेम्बर द नंबर ऑफ द क्वेश्चन बट ये लास्ट एक्सरसाइज के लास्ट पेज पे है। प्लीज लुक एट द आंसर। हाँ अंशुल देखना वो उसमें देखना ये अपने HCV में HCV का क्वेश्चन है। हाँ देख, see if your answer is matching. हाँ, तो आंसर देख के जनरली जो है तो हालत खराब हो जाती है कि ये क्या है, ये क्या है। मैच कर रहा है। स्क्वायर वेयर नहीं आता था उसमें, मुझे याद नहीं।
तो वो होल स्क्वायर रूट आता है ना?
नहीं, ये जो साइन थीटा के इंडिविजुअल टर्म्स आते हैं कॉस थीटा के, इनका स्क्वायर नहीं आता। देखो यार, मतलब यू आर लुकिंग एट द आंसर, सो इफ इट इज मैचिंग इट्स
सर है टर्म्स हैं।
हाँ सर एक मिनट, cos स्क्वायर थीटा रहेगा, वो मैं 2 लिखना भूल
और
गया।
साइन स्क्वायर थीटा भी है सर।
हाँ
अच्छा, साइन स्क्वायर भी है ना, वही वही मैं सोच रहा था, स्क्वायर स्क्वायर आता है।
हाँ सर, वो मैं 2 अपने आंसर में लिखना भूल गया टाइप करते समय।
अच्छा, so why are you getting this mismatch? Why this huge mismatch? So if you remember in the last class I told you that there are only a couple of things which can go wrong. Conservation of momentum itself is not a problem. Conservation of momentum itself is an extremely easy and intuitive concept. Problem arises when you start measuring velocities. When you start measuring velocities from different frames. If you are measuring the velocity of this block with respect to the earth, with respect to the ground, then whatever you have written will be wrong. Because let's say that at the time when the block reaches the bottom, its velocity is v1 and the velocity of this is v2, let's say. But ये v1 क्या है ये? This v1 is the velocity of the block with respect to the wedge. You actually have, or I have, drawn the velocity of the block with respect to the wedge. With respect to the wedge, उसकी velocity along the incline होएगी. लेकिन with respect to the ground, इसकी velocity ये नहीं होने वाली. This is not the velocity with respect to ground. Okay. So what you need to do is that before you apply the law of conservation of momentum, you need to figure out what the velocity of this block will be with respect to the ground. So the way that I am going to do this is I'm going to say that, look, I know for sure that the velocity of this guy will be horizontal. This is a given. Okay. And we have had this discussion before. And I am going to assume that the velocity of this guy is going to be some Vx, some V1. Because I have no idea what the direction of velocity is. इससे पहले जो मैंने एरो बनाया था, अगर आपने भी वो एरो बनाया, बिल्कुल ही गलत assumption है, in the sense that ground के respect में वो direction of velocity नहीं रहे. So if I apply the work energy theorem, I will get plus mgh work done by Earth, work done by everything else is 0, is equal to the final kinetic energy, which is half mvx square plus vy square plus half mv square minus initial kinetic energy. Yes, vx should be left, yes. But it, like I said, it does not really matter. Okay, so you don't. So what you have to realize, Tulika, is that the velocity will have two components. That is what is of the uttermost importance. Individual components का direction क्या है, that will not matter. Vy अगर मैं ऊपर भी ले लूँगा तो कोई फर्क नहीं पड़ेगा. And along the x-axis, then the momentum should be, initial momentum is 0, should be mvx plus capital MV. Right? So Tulika, you see, automatically I am getting Vx and V as opposite, minus sign automatically aa gaya usme. So how many unknowns do we have and how many equations do we have? Well, we have applied the work energy theorem. We got one equation. We have applied the law of conservation of momentum and we got another equation. But unfortunately, there are three unknowns. Right? Vx is unknown, Vy is unknown, and V is unknown. So I require one more. हाँ, बताओ कहाँ से आएगा?
Wedge constraint.
Very good. Yes. So however hard we try, we bring in work energy, we bring in conservation of momentum, we bring in pseudo forces, so that we don't have to worry about constraints. But ultimately, if in a question you do end up with a number of equations which are less than the number of variables after having applied everything, then it is only the geometrical nature of the problem which is going to give you another equation. Therefore, it has to be constraints. So the constraints in this must be that the velocity components in this direction, perpendicular to the interacting surfaces, must be equal. Okay? So मैं यहाँ पे ये v बना लेता हूँ और ये vx और vy के कंपोनेंट्स निकाल देते हैं. तो ये लाइन नॉर्मल रिएक्शन की लाइन है, तो ये वर्टिकल से वही एंगल बनाएगी जो वेज का एंगल है. ये एंगल 90 माइनस थीटा हो जाएगा और ये एंगल 90 माइनस थीटा हो जाएगा. So the constraint equation gives me Vx sine theta plus Vy cosine theta must be equal to V sine theta. Okay? And you can divide by cosine or you can divide by sine, whichever you prefer. So you can write this as Vx plus Vy cot theta is equal to V. This is the third relation. So relation number 1, relation number 2, relation number 3. You have to get rid of Vx and Vy, and you have to. It's very easy actually now. Vx की वैल्यू यहाँ पे रखनी है तो ये m कैपिटल M V अपॉन M रख देंगे और Vy की वैल्यू जो है वो यहाँ से उठा के रख देंगे यहाँ पे. We should get a single equation with only V, and that should give us the answer. Right? अगर जैसे तुलिका ने सजेस्ट किया that I take Vx on this side, then in this case Vx का component इधर आएगा और Vy का component इधर आएगा. So I'll have to take this component, I'll have to take this component minus this component is equal to V sin theta. लेकिन यहाँ पे Vx का component इधर ही आ रहा है, Vy का component इधर ही आ रहा है, V का component same direction इधर आ रहा है. So both of them I simply equate. Okay. Okay. Sure. So I hope this is clear that work energy
पिछले क्वेश्चन
theorem.
में ऐसा नहीं किया, इस बार क्यों?
क्या क्या कौन से क्वेश्चन में नहीं किया?
जो इससे पिछला वाला क्वेश्चन था जस्ट.
हाँ मैंने एक्चुअली किया
की जरूरत ही नहीं
पड़ी. दूसरे वर्ड्स में किया ना. मैंने बोला ना कि यहाँ पे वेलोसिटी और यहाँ पे वेलोसिटी सेम हो गई ना. So basically what I'm saying is that look, these are two surfaces in contact with each other. Therefore, the velocities of the objects in this direction must be same. The only difference between this diagram and this diagram is that the yellow line here is slanted and over there the yellow line is horizontal. That is the only difference. दूसरा डिफरेंस ये है ऑफ कोर्स कि यहाँ पे जो वेलोसिटीज हैं ये येलो लाइन के अलोंग है और यहाँ पे जो वेलोसिटीज हैं वो येलो लाइन के अलोंग नहीं. ओके चलो ठीक है. So today I have shown you that law of conservation of momentum is really a secondary, sometimes primary, but mostly secondary tool to construct another equation when multi-particle systems are involved. Okay. Homework के लिए हाँ.
सर अभी पिछले वाले क्वेश्चन में सर उसमें अगर हम Vx को उल्टा ले लेते तो
हाँ,
हमारी थर्ड इक्वेशन में साइन बदल जाता, तो उससे कोई आंसर पे
कोई
फर्क
फर्क
नहीं
नहीं,
पड़ता।
कोई फर्क नहीं। हमारे आंसर पे कोई फर्क नहीं पड़ेगा। यहाँ पे एक माइनस आ जाएगा, लेकिन यहाँ पे भी तो माइनस आएगा ना,
हाँ ओके ओके, हाँ हाँ।
कोई फर्क नहीं। प्लीज डू दिस क्वेश्चन थोड़ा सा केयरफुली, बिकॉज आई नो, थोड़ा सा I really like this question actually. You can be sure that there is something very weird going on. So the block is released on the other block. B ratio of m by n, so that block climbs wedge only once. ठीक है ना, ये दो सेपरेटेड है, मतलब ये दो अलग अलग वेजेस हैं, बट इनके सरफेसेस इस तरीके से हैं दैट, and I have to be very careful. I cannot give you a question like this. In fact, if you ever see a question like this, then it is wrong. I cannot give you a question like this, and I'll discuss why I cannot give you a question like this, because when we do collisions, then I'll discuss ये question गलत क्यों। ये जो surface है ये smooth आना चाहिए, तभी ये question सही रहेगा।
फिर वेलोसिटी
ये
अब्रप्टली
वाला जो,
चेंज हो जा रहा है नीचे वाले,
हाँ
वेलोसिटी का सडनली अपर कंपोनेंट मतलब।
हाँ हाँ, collision हो जाएगा ना वहाँ पे, external impulsive force लग जाएगी। So try to do this as homework. You can start with HCV, पूरा collisions को छोड़ के बाकी सारे क्वेश्चन आप कर सकते हैं। लिख लिया, हो गया ना, क्वेश्चन लिख लिया सबने, स्क्रीनशॉट ले लिया
यस
मतलब।
सर।
चलो ठीक है, send me on WhatsApp after you solve. I'll see you guys in the next class. चलो बाय बाय। चलो guys।